Okay, moving on to the last example for question 13a of the chem bonding tutorial. We are supposed to explain why iodine is insoluble in water. Okay, so iodine we know has a simple molecular structure. Okay, so for iodine, because it's non-polar, okay, the type of solid-solid interactions would be a weak ID-ID. For water, it will be hydrogen bonding between the solvent-solvent. And since iodine cannot form hydrogen bond with water, the type of solid-solvent interactions will also be only a weak ID-ID. So if you compare the weak ID-ID to the hydrogen bonds, you realize that it's going to be insufficient to compensate, alright, the amount of energy released from the solid-solvent interaction. It's not going to be sufficient to overcome hydrogen bonds between water molecules, and that's why you expect to be insoluble. Okay, so let's take a look at the answer. Energy release, alright, again we're looking at the solid-solvent interaction. In this case, since iodine cannot form hydrogen bond with water, you only have a weak ID-ID, solid-solvent interaction. Okay, and I hope at this juncture you guys are also asking yourself why iodine cannot form hydrogen bonds with water. So recall what we went through in question 10 about the criteria for forming hydrogen bond. You need F, O, or N with lone pairs. Alright, iodine is not one of the elements there. Okay, so the energy released during this solid-solvent interaction is insufficient, alright, to overcome the stronger hydrogen bonding. In this case, the hydrogen bonding between water molecules. Alright, it's your solvent interaction, and then as well as the weak ID-ID between your iodine molecules, which is your solute interaction. Okay, so it's insufficient to overcome, and that's why we can conclude it's going to be insoluble. Okay, if not, we're going to speed things up a little bit now that you guys understand the framework in which we explain for solubility. We look at these three interactions: your solid-solvent versus solvent-solvent and solid-solid interaction. We're going to apply it in the next context of question 13b, which is on hexane. So in this case, hexane is our common solute. But now we have two solvents. Right? We have water as well as tetrachlorometane. We have solvent 1, solvent 2. Okay, so again, I'm going to use the structure and bonding approach to explain for the answer. In this case, you realize that hexane, water, tetrachlorometane, they all have their simple molecular structure. Okay, they are all simple molecules. Okay, we're going to investigate one by one. For hexane, the type of IMF we expect will be your ID, because why? Hexane we know is going to be non-polar. How do I know it's non-polar? C and H, very similar electronegativity. There's no polar bonds. So it's quite clear it's going to be non-polar. For water, we discussed this extensively. It will be your hydrogen bonds. So this will be your solvent interaction. In this case, for the ID for hexane will be a solute interaction. Okay, and for the solvent number 2, tetrachlorometane, CCl4, you have a tetrahedral shape around the carbon because of the 4 bond pairs, 0 lone pairs, and that's why it's tetrahedral. Now one look at this, you guys will realize that the dipole moments can cancel out. So CCl4 is also going to be non-polar. So the solvent-solvent interaction in this case is going to be ID. So with this, let's take a look. We have the context number 1, not miscible in water. So if you do a comparison with the earlier example, it's similar to like iodine, simple molecular, right? ID, not soluble in water. So that one can be quite easily explained. Alright, the next one is about explaining why hexane is soluble in tetrachlorometane. Okay, so we're going to use those two frameworks. So for hexane, the type of interaction will be solid-solid interaction will be ID, solvent. For water, will be hydrogen bonds. the solid-solvent interactions will be a weak ID-ID, and that's why it's going to be insoluble. So the explanation is exactly the same as why iodine is insoluble in water. So energy released during the solid-solvent interaction, which is your weak ID-ID form between hexane and water molecules, right? Weak ID-ID between hexane and water molecules, then is insufficient to overcome the stronger hydrogen bonds, which is a solvent-solvent interaction, alright, as well as the weak ID-ID between the hexane molecules, which is a solute-solute interaction. So I'll just color code for you guys over here. Solvent-solvent, and last one, this is a solid-solvent. So in this case, this interaction here cannot outweigh, alright? Cannot overcome the solvent-solvent interaction and solid-solid interaction. That's why hexane immiscible in water. In the case of tetrachromethane, right, you have ID-ID for your solvent-solvent interaction, you have ID-ID for your solid-solid interaction. Between hexane and tetrachromethane, there are two non-polar substances that are going to be forming ID-ID. Okay, so in this case, you can see this we have discussed earlier on. Alright, for hexane, for CCl4 as non-polar solvent, we have weak ID-ID, and for solid solvent interactions, we're going to also have ID-ID. And that's why, because you can see it's ID-ID, 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 they are compatible, comparable in strength, we expect it to be soluble. So, in the phrasing, same thing, energy release, formation of the weak ID-ID between hexane and CCl4 molecules, that is your solute-solvent interaction, is sufficient. Notice, you explain why it's soluble, sufficient to overcome. What's the solute interaction in this case? The weak ID-ID between hexane molecules, so it's a solute-solute interaction. Alright, and the solvent-solvent interaction, in this case, is also ID-ID. Okay, so I'm color coding based on the schematics below so that you guys can see which is the solute-solvent interaction, which is the solid-solid interaction, which is the solvent-solvent interaction. And because it's sufficient to overcome for the energy released during solid-solvent interaction is sufficient to overcome solid-solute and solvent-solvent interaction, you expect hexane to be soluble in tetrachromethane. Okay, with that, we're done with question 13.